All right. Hello, class. What we're going to do today, and it's Monday, so you're going to be working through these 3 pages in your packet. Okay. If you want to try them on your own, try them on your own. I'm going to actually go through all 3. If you're stuck, don't know where to begin, follow along. The only thing new that we didn't talk about in the last section was the multiplicity here. Okay, so there's something called multiplicity for a vertical asymptote and multiplicity for an x-intercept. And there's something that the multiplicity tells you about how you draw your graph. Okay, so what we're doing here, we're graphing rational functions. We're identifying the asymptotes, vertical, horizontal asymptotes, and behavior asymptotes, which are typically horizontal asymptotes. For our purposes today, it's just going to be horizontal asymptotes. And then we can find our removable discontinuities, the domain, and so on and so forth. Okay, but the multiplicity is new. So you might at least want to watch the first one, at least that part of it, and try to do these 3 problems. If you're stuck at any point, I'm going through entirely from beginning to end all 3 of these problems on 206, 207, and 208. Okay, so we're going to look at the first. We're going to look at the function itself. Okay, we've got an x minus 2 on the top. On the bottom, we want to factor that. That becomes x plus 5 times x minus 2. Okay, you notice the x minus 2 factor occurs in the top and the bottom. You can cancel that. The simplified version is 1 over x plus 5. Okay, don't just cancel and forget it. Something that cancels is a key aspect of your graph that we're going to talk about. Okay, the domain. The only values that don't exist in your domain are the values that would make your denominator 0. -5 would make your denominator 0, and so would positive 2. Right? Even though that canceled, we still have to remove that point from our domain. So our domain is -infinity to -5, union with -5. Notice we don't include the -5 to positive 2, don't include the positive 2, and then 2 to infinity. Okay, remember what a removable discontinuity is. Removable discontinuity happens for any value of x that makes your denominator 0, but that factor also cancels. So the value of x equals positive 2, that's your x coordinate. Remember, a removable discontinuity is just a single point, so make sure you give an ordered pair. Now you're going to plug that x value in. You can't plug it into here. You get 0 on top and 0 on the bottom. You plug it into the simplified version. That tells you where that point would have been if it did exist. So 1 over 2 plus 5, 1 over 7. Okay, vertical asymptotes. That comes from values that make your denominator 0 but don't cancel. So x equals -5. Okay, and let's talk about the vertical asymptote multiplicity. Okay, so we know there's a vertical asymptote at x equals -5 because we have an x plus 5 on the bottom. Now, how many times did this x plus 5 occur? Just once. So the multiplicity is 1, which is an odd number. Okay, the multiplicity is 1, but really we only care if it's even or odd. Okay, we're going to talk about what that means. I will tell you right now, what it means is if it's odd, it means your graph is going in opposite directions. As you approach that asymptote. So from the right and from the left. Once we draw it, I'll show you what that means. And that might not make a whole lot of sense right now. Okay. And behavior asymptote. Well, for our purposes, this is going to be a horizontal asymptote. We look at, is this top heavy or bottom heavy? The degree in the top is 0 because that's 1, which is a constant, which is 0 degree. Degree on the bottom is 1. So the degree of bottom is bigger. So it's bottom heavy. Anytime you have a rational function that's bottom heavy, your horizontal asymptote is y equals 0. Okay, your x-intercept. So your x-intercept happens when y is 0. Okay, so here's our function. We set the entire function equal to 0. Is that ever possible? In order for a fraction to be equal to 0, the numerator has to be 0, and it looks like the numerator can't be 0. You might be thinking, well, we could have set the numerator equal to 0 here. The problem is when x is 2, it makes your numerator and your denominator 0, which is undefined. Okay, so that doesn't work. It doesn't make this thing equal to 0. It makes it undefined. Okay, so there's none. No x-intercepts. Okay, y-intercept happens when x is 0 And this one's fairly easy to do. Plug in 0 for x, and you get 1 over 5. 0, 1 over 5. Okay, let's go back to the x-intercept. Since there was none, this is kind of irrelevant. It's neither even nor odd. Okay, in the next problem, we're going to see what it means when you have a multiplicity here for your x-intercept. Okay, so let's graph. I like to start with my asymptotes. So y equals 0 is an asymptote. X equals -5 and as an asymptote. Okay, and then you've got your y-intercept is 0, 1/5. 0, 1 over 5. What else? Your x-intercept, there's none. So let's just pick a couple points to the right and a couple points to the left of your asymptote. Okay, so I'm going to pick points like maybe -7 and -6. And then to the right of the asymptote, so -4 and -3. And plugging in -7, so fairly easy to plug it into the simplified version, you get -1/2. Plug in -6, you get 1 over -6 plus 5, so 1 over -1, which is -1. Plugging in okay, let's plug in -4. You might want to plug in something in between, maybe a -5.5. You could do that. -5.5 if you want to be a little more thorough. Then you get a -1/2 on the bottom. 1 over -1/2 is -2. Okay. Plug in a -4. You could also do a -4.5, but we'll just go with -4. Our y value is 1. -3, our y value is 1/2. So let's plug those in. -7, -1/2. -6, -1. -5.5, -2. Okay, so we can see that this is going to look like this. Okay, -4 gave us a value of +1. -3 gave us a value of 1/2. And we also know we're going to go through this point over here. So our graph looks like this. Remember, you're getting infinitely closer to these. Okay, let's go back to this vertical asymptote multiplicity. The vertical asymptote, the multiplicity was 1 because we knew there's a vertical asymptote at x equals -5. Because when x is -5, it makes the denominator 0 and nothing cancels. Okay, this x plus 5 only occurs once. It's like x plus 5 to the first. If it said x plus 5 to the second, that would be a multiplicity of 2, which would be an even number. So our multiplicity would have been even. Okay, we'll see that on the other problems. Okay, but since it's odd, and if it said x plus 5 to the third, the multiplicity would be 3, which would also be odd, and they would go in opposite directions. And what I mean by opposite directions, look at your graph as you approach this asymptote of x equals -5. If we're approaching that asymptote from the right, our y value is going up to +infinity. If we're approaching that asymptote to the left, our graph is going off to -infinity. Okay, they're going in opposite directions, from the right up, from the left down, opposite directions. If the multiplicity were even, they would be going in the same direction. So from the left, you'd be going up, and from the right, you'd be going up, or they'd both be going down. Okay, if that's confusing, we'll see that in another one. Okay, I'm going to go to the next problem. Okay, so we've got this one. As you can see, there's some multiplicities that are different here. You've got an x minus 2 to the second. So this thing will tell you there's a multiplicity of 2. Here you've got x plus 4 to the second. That's a multiplicity of 2. The x minus 3 is to the first. That's a multiplicity of 1. Okay? Come back to that in a moment. Okay, our domain, the values that don't exist on our function are when x is +3 or x is -4, because they make your denominator 0. So we're going to go -infinity to -4 in union with -4 to +3, union with 3 to infinity. Okay. Are there any removable discontinuities? Remember, a discontinuity, you're looking at a value of x that makes your denominator 0, but that factor will cancel with the factor on the top. Okay, there's no factors that cancel, so there are none. Let's go to the vertical asymptotes. So there's a vertical asymptote at x equals 3. That's x minus 3 to the first, so the multiplicity for that asymptote is odd. It's odd because it's only 1. The multiplicity is just 1, which means opposite direction. Okay, and then x equals negative 4 is your other asymptote. X plus 4 is squared, which means it occurs twice, which is an even number. Your multiplicity is 2, which is even. You don't really care about the number so much as even or odd. Okay, and that means same direction. Okay, so from the right and to the left of this asymptote, your graph is either both going up or both going down. Same direction. Okay, we'll revisit that when we get there. Okay, end behavior asymptote. So that's the one we look for rational functions, top heavy or bottom heavy. The degree on the top, if you multiply all this out, you have an x squared on the top. So the degree on the top is 2. Degree on the bottom, if you multiplied this all out, you'd have an x, and then here would be an x times an x. So this thing is squared, so you have an x squared here times another x. Your degree on the bottom is 3. Degree on the top is 2. So it's bottom heavy, and anytime your fraction or your rational function is bottom heavy, you've got an asymptote, horizontal asymptote at y equals 0. X-intercept, you're going to look at values of x that make your whole function 0, which means your numerator has to be 0. So that's going to be when x is 2. So that's x-intercept 2 comma 0. And the multiplicity of that, because x minus 2 on the top occurs twice, the multiplicity is even. Okay, it's 2, which means there's a bounce. Okay, I'll show you what that means on the graph when we graph it. Okay, the y-intercept happens when x is 0. So if you plug in a 0 for x, just plug it in 0 for x, plug in a 0 for x. For your y value, you're going to get 0 minus 2, negative 2 squared, which is 4. And on the bottom, you get negative 3 times 0 plus 4 is 4. 4 squared is 16. 16 times negative 3, you'd get negative 48. Simplifying, that's 0, negative 1 over 12. Okay, so you're just plugging 0 in for your x and simplifying what's left. Okay, let's graph. I'd like to graph my asymptotes first. Y equals 0. X equals negative 4. X equals positive 3. Now let's put any points that we can onto our graph. X-intercept is 2 comma 0. Y-intercept is 0, negative 12. I'm sorry, 0, negative 1/12. Okay, so this point is 2 comma 0. That's 0, negative 1 over 12. Okay, so we know we're going to go here. We know we're going to go here, go through these 2 points. And this is the only place you hit the x-axis. Okay, so now we're going to pick some values to the left and to the right of these asymptotes. So let's make a table of values. Moving at negative 4, let's say negative 6 and negative 5, and negative 4, negative 3, and negative 2. Okay, and then we'll pick a couple close to here. You already have negative or positive 2. Let's do, let's just do to the right of here. So 1, 2, 3, 4, and 5. We know our 0, we've got negative 1/12. Let's do 4 and 5. Okay. Plugging in negative 6. Okay, and plug in negative 6 into your function. What you get, let's look at our function. Negative 6 minus 2 is negative 8. So we've got 64 over negative 6 minus 3, negative 9 times 4. So we've got 64 over negative 36, which simplifies to negative 16 over 9. Okay. Plugging in negative 5. Negative 5 minus 2 squared. I got a 49 on the top. On the bottom, you've got negative 5 minus 3, so negative 8 times negative 1. So that's going to give you 48 over 8. So that gives you, sorry, that's a negative up here, right? Negative 8 times, oh, that's squared, so that's a positive 1. Okay, so 48 over negative 8 gives you negative 6. Okay, plugging in negative 3. So these are 25 on the top and negative 6, so 25 on the top. Negative 6 times 1. So what do we get? Negative 25 over 6. Okay, plugging in negative 2. You're going to get 16 on the top. On the bottom, you get negative 2 minus 3. So negative 5 times 4. So what do we get? Negative 4 over 5. Okay, these are kind of a pain sometimes to plug in, but you're just plugging in numbers. So 4 minus 2 gives you 2 squared, which gives you 4 on the top. And then 4 minus 3 is 1. And then 4 plus 4 is 8. So that gives you, 8 squared, right? So that gives you 4 over 64, or 1 over 16. And then 5, you get 5 minus 2 squared on the top, so you get a 9 on the top. 5 minus 3 is 2. 5 plus 4 is 9 squared. 81. Okay, so that's going to be 1 over 18, right? Okay, so negative 6. 1, 2, 3, 4, 5, 6. Negative 16 over 9. That's a little less than negative 2. Negative 5, negative 6. Negative 3, negative 25, 6. That's a little bit more than negative 4, or further than negative 4. Okay, negative 2, negative 4/5. Okay, and then we're going to go through this point, and what do we have? Okay, and we've got this over here, 4 comma 1/16. About right there, and 5 comma 1/18. Okay, so let's look over here. Now, we know that we have to go through this point and this point. We have to approach this asymptote down here. Okay, we know there's no x-intercepts over here, so we can't cross that. We know it's going to go like that. Okay, now these points. Now, remember that multiplicity for your asymptote? So here's our asymptote of x equals negative 4. X equals negative 4. The multiplicity was even because the multiplicity was 2. X plus 4 squared. Okay, which means same direction. So coming from the left and coming from the right to this asymptote, we know this one's down, this one has to be down also. So a lot of this is just confirming. Okay, we're going to go through here, we're going to go through this point, we're going to go through this point here. Now the multiplicity of this point, this x-intercept, was 2, which means it's even, which means it's a bounce. A lot of times you pass through your x-intercept and end up on the other side. But in this case, you just barely touch it and then you come back in the opposite direction. You bounce off of it. Okay, so if you're either bouncing off of it, if you're below it, you're going to touch it and stay below. If you're above it, you're going to touch it and stay above. You're going to bounce off the x-axis. So that's what bounce means. And you know there's a bounce if the multiplicity of that x-intercept is even. We know the multiplicity, just reminding that that x-intercept is even because how did we know that 2 was there? From the x minus 2 on the top. And the x minus 2 has an exponent of 2. It's x minus 2 times another x minus 2, the multiplicity. Basically, how many times that factor occurs is 2, which is an even number. So we've got a bounce. Okay. Then over here, we know we go through this point. We know for this asymptote, the multiplicity for this asymptote, x equals 3, was odd. Okay, we know that because the x minus 3 is only to the first, which is an odd number. So we know approaching this asymptote from the left, if this side's going down, this side's going up. Okay, we know there's no more x-intercepts over here, so we can't cross here. So we know that that's going to go this way. Okay, so this graph looks a little goofy, but we're analyzing the graph just based on these things we know about the actual function. Okay, so your graph's going to look like that. At this point, you can go into your calculator and you can graph it and confirm it. But I want you to try to do these, try to come up with the graphs the best you can before you actually plug them in your calculator. Okay, and we'll do one more. If you feel comfortable, go ahead and do the other one on your own. Come back if you have questions. Okay. And the next one. Okay, first thing you want to do is you want to factor everything. So on the top, you get x minus 2, x minus 3. On the bottom, you've got x plus 1, x plus 1. Or x plus 1 squared is fine. Okay. Domain is everything except x equals -1. So you've got negative infinity to -1. Union with -1 to infinity. Okay. Are there removable discontinuities? Remember, you're looking for something that makes your denominator 0, but that factor cancels with something in the numerator. And there are none. Vertical asymptotes, well, x equals -1. Now that x equals -1, you know because of the x plus 1, and that x plus 1 occurs twice. So your multiplicity for that asymptote is 2, which is even. It's 2, which is even. Which, remember that says, if it's even, that means same direction. So as your graph approaches that asymptote from the left and the right, it's either going up on both sides or down on both sides. Okay. Your end behavior asymptote or your horizontal asymptote. Okay, you look at top heavy or bottom heavy. Degree on the top is 2 because of the x squared. Degree on the bottom is 2 because of the x squared. And when it's even, when it's the same degree on the top and the bottom, you look at the lead coefficient. Here is a 1. You divide that by the lead coefficient in the bottom. 1 divided by 1. Your horizontal asymptote is at y equals 1 over 1, which is 1. X-intercepts. X-intercepts are values that make your entire function equal to 0. So if we set this equal to 0, this function is equal to 0 when x equals 2 or when x equals 3. So we've got 2, 0, and we've got 3, 0. Okay, that x minus 2 only occurs once. So that x-intercept has a multiplicity of 1, which is odd. 3, 0, x minus 3 is just to the first. There's only one x minus 3, so this is also odd. 1. So that means you're going to just cross right through, right? For both of these, cross over the x-axis at that point instead of bouncing. If this were even, you would bounce off the x-axis, but since it's odd, you're just going to cross through. I'm just going to say cross through. Cross through the x-axis. Okay, y-intercept happens when x is 0. Plug in 0 for x. 0, 0, 6 on the top, 0, 0, 1 on the bottom. So I got 0, 6. Okay, start with our asymptotes. We've got a horizontal asymptote at y equals 1. Vertical asymptote at x equals -1. Y-intercept is 0, 6. 1, 2, 3, 4, 5. 0, 6. And let's pick some values to the left and the right of here. Okay, it looks like you're going to go up here. There's no x. There's there's 2 x-intercepts at 2, 0, and 3, 0. So, okay. Now this is tricky because a lot of times you think it doesn't feel right to cross over a horizontal asymptote, but to get from this point to this point, we definitely have to cross over this horizontal asymptote. Okay. Now, usually an asymptote is something you get infinitely close to, but you never touch. Well, that's at the end. So that's kind of why we call it an end behavior asymptote. At the behavior of this function at the ends, as you go off to infinity or as you go off to negative infinity, okay, you're getting closer and closer to that asymptote, but you don't touch it. But you are able to cross through the asymptote somewhere on the interior of your function, okay, just not at the ends. Okay, so let's take some, I'm going to look at, if we go to -2, and I'm going to put this down here because I kind of know what's going to happen if we plug in a -2. Okay, so we're going to get, what do we get? -4 times -5 over -1 times -1. So we end up with 20 over 1. Okay, so -2 comma 20, that doesn't help us a whole lot. Let's go to -3. -3 minus 2. Oops. Okay, -3 minus 2 is -5. -3 minus 3 is -6. On the bottom, I've got -3 plus 1, so -2 times -2, which is 4. So I've got 30 over 4, which is 7.5. So if I go to -3, I've got 7.5. Okay. I know there's no more x-intercepts. I'm going to test a couple points over here. Let's do like -6 and -7, just so we can get an idea what this looks like. Okay, if you plug in -6, you can go ahead and do that, but what you're going to get is 2 and 22/25. -7, you would get 2.5. So at -7, 1, 2, 3, 4, 5, 6, 7, you'd get 2.5. -6, you get 2 and 22/25, so almost 3. Okay, so you're going to get something that looks like this. Approach that asymptote. This is going to go off this way. Okay. Now remember the multiplicity of this vertical asymptote. X equals -1. The multiplicity was 2, which means same direction, which means from the left, we're going up. Same direction means from the right, we're also going up. So we're going to go through this point. It's also going to go up. Okay, we have to cross through here and here. Now we're not bouncing because the multiplicity of both of these is 1, which means we're going to cross through. So kind of makes sense. We're going to go through here. We're going to cross through. And then we have to cross through this one. Okay. And then we can plug in, try a few more. We could plug in a few more points over here, but we're going to end up approaching this asymptote over here. And we're going to stay below it. Okay. But approaching a y value of 1. Okay, so if you wanted to plug in a few more points over here to verify and confirm that's what happens. But we know that we cross through here and cross through here. It's not a bounce because of the multiplicity. All right, I hope that made sense. Hope you enjoyed the video. Thank you all for watching, and I will see you all very soon.